Okay, take a look on your iPad and find 9.7 day 2. The notes are posted if you want to do it that way. If you want to just take a piece of paper and follow along with me because you don't have your iPad today, whatever. But you do need to follow along with these problems. By the end of the hour, you're going to know how to do horizontal asymptotes. We learned verticals yesterday, but now you're going to learn horizontals. And you're also going to learn how to write equations based on a graph that has a hole in it. One more thing I'm going to add to that list is if I give you the asymptotes, given asymptotes, you can write an equation. All right, those are the things you're learning today. First, I want to review. That one, it's like the third slide if you have found the notes for today. I think it's slide 3. Is it? Okay. Then find that one, factor the top, factor the bottom, see what cancels. And the only one I don't expect you to do yet is this. You do not know how to do that. I'm going to teach you that today. So do the other parts of it. Okay? Go ahead and try that one on your own. I'll be walking around and checking on how you're doing after I get attendance. Okay, before we get too far, I want to make sure you factored right. You should add 2 sets of parentheses on top and the bottom. In the top, it's going to be x and x and x and x on the bottom. And then to be able to make a -4, it multiplies to -4 and it adds to 3. It should be +4 and -1. Do I have that right? All right. Then on the bottom, it should be multiplies to -3 and adds to 2. It should be a +3 and a -1. All right. Now, what cancels is this. And then what you really should do is write the resulting function. A lot of kids skip that part, and I'm telling you, it's so much easier for you if you have this all written out because you need it to find the whole. And if you try to not write this out, it's just really messy to try to do the whole part. All right, domain. These are the 2 areas we have to watch out for because if the bottom ever becomes 0, anything divided by 0 is called undefined. So we have to be careful that we don't have a -3 or a 1 as our answers. So it's all real numbers except x cannot be -3 and x cannot be 1. And because I know some of you like to be extra smart, I want to make sure you know how you really should say this. X is an element of R, and x cannot be -3 and x cannot be 1. So this part is optional, but it is the official way you're supposed to say it, and you'll look smarter if you write it that way on the test, if you can remember. X is an element of the real numbers. Okay, the next part, we're skipping the horizontals because that's what you're learning how to do today. And we're going to go to verticals. The verticals, these 2 things, I like to think of it this way. These 2 things that crash my function, they're either asymptotes or holes. You just have to pick each one of them and say, okay, what's this one? Is it a hole or an asymptote? So, what's this one? Is that a hole or an asymptote? That's an asymptote. So I'm going to write it x equals -3. The only place you ever use not equals is in a domain. So you're not going to ever have these other signs be not equals, but you need not equal signs in the domain. And then the last thing is the hole. Well, the other one then, this one must be the hole. And that's 1, comma, and then to figure out the other part of the hole, as I said before, you'll need to use this thing. So I'm going to put in x is 1. And I get 5/4. 5/4. Raise your hand if you think you get that one right on the test on Friday. Okay, good, because there's a test coming on Friday, and those are the things you need to know so far. Now, this horizontal asymptotes part, to be able to do that, we have to look at the equation and determine from looking at the original equation, there's 3 different ways that this equation could come out. It could come out to be a bigger on top, a bigger on the bottom, or a same on both. This is the part where just watch for a minute before you take notes on it, and I'll summarize with nice, succinct, simple notes that you need to write down. But first, we need to understand what's bigger on the top versus bigger on the bottom. This one seems like it's way bigger on the top because it's got a +5 there, but it's not. It's all about the degree. What degree is the one on top? 2, degree 2. What's the degree of the one on the bottom? 2. And therefore, it's the same on both. We call it an SOB. All right. Yes, I'm aware that has other connotations in the real world, but all right. And they actually are kind of an SOB to figure out later, but for right now, they're a same on both. Okay, the next is if I make it a little bigger on the top. So let's say it's x to the third. Now it's bigger on the top. It has nothing to do with the plus 5. It's just that it's degree 3 on top, degree 2 on the bottom. That's called a bot, bigger on top. And of course, if I make them the same, degree 3 and degree 3, my check forging skills are strong. X to the third over x to the third. Now I've got the same on both. I was supposed to make it bigger on the bottom. Okay. Anyway, this is the same on both. Okay, now if I want it to be bigger on the bottom, I have to forge in a 1 there. I'm always paranoid that on someday when on my credit card receipt, some person is going to write in like a $100 tip for themselves. You know, like let's say I give them a $10 tip. You know, so you write in a plus 10 on the bottom of your thing. All it would take is for them to write an extra 0 in there, and poof, I just gave them a $100 tip on my credit card. And I don't know how you'd be able to prove it later that I didn't write in 100. If they just write it with the same color pen you used and everything, I don't know how they stop you. Anyway, yeah, always write in purple pen. That way. All right. So, this one's pretty obvious, but I still would have people say it's bigger on the bottom, but it's not. What is it? It's a sob. It's the same on both. Okay, how about now? Bob, bigger on the bottom. How about now? Bigger on top. Okay, so now, all of the kinds I just showed you have the potential to have asymptotes because they are fraction functions. They're called rational functions. They got a big fraction involved. This big fraction bar right here makes them probably have an asymptote. And here's how you tell. If they are a same on both, then the asymptote is going to be a ratio of the lead coefficients. But just write down y equals ratio. If they are a bigger on the bottom, then their y equals 0 plus the outside. If there's anything outside the fraction, you need to add that to 0. I'll show you an example of that in a minute, but write this down. It'll help you remember it. 0 plus outside. And the last one is that it's a bot. That stands for bigger on the top. And if it's a bot, there are none, as in there's no asymptote. It's totally different than 0 because that means it'd be an asymptote at 0. We don't say y equals 0. That's different. Y equals none. There is no asymptotes if it's a bot. So since there's no and bot, I like to call them no bots. Kind of like robots. All right. So Bob is 0 plus the outside, and I will often say, who tells you the horizontal asymptotes? And then you can say Bob. And then it's either bigger on bottom, bigger on top, or same on both. Okay, so here are some problems and what the answer would be. If you had to graph this, that's a really weird 3. I'm going to try again. X to the third plus 5 over x to the second. I would say that that's a bot, bigger on the top. And if you graphed it, you'd find there's no bots, as in no asymptotes. Okay? No asymptotes for this one. It's not like all of them have asymptotes. Most of them do, though. All right, so let's say we have a 3 on the bottom now. Now it's a what? It's a sob. It's a ratio. And the ratio kind is a ratio of the lead coefficients. This one would be a same on both, and thus the answer would be a ratio of the coefficients. That's not a coefficient. That's a constant. That doesn't count. So that's a 1 and that's a 1. So y equals 1 over 1. Y equals 1. I'll do another one like that, where it's the same on both. Wait, that's not same on both. What's that one? That's a Bob. All right, I'm going to make them same on both first, though. If it had been a same on both like this, then it's a ratio. So what's the answer? 3 over 2. If you graphed it at 3 over 2, there would be an asymptote running through. So 3 over 2 is the same as 1.5. So like right around there. There'd be an asymptote going right through there. All right. And what if it was bigger on the bottom, like I made it in the first place? What's the deal for Bob's again? 0 plus the outside. Is there anything outside this fraction right now? So it'd be 0 plus nothing, so it's just y equals 0. Okay, so Bob is a 0 unless there's something out here. Why? Because, do you know by now that if you take your function and go like plus 7 here, do you get that the whole thing's going to move up 7? That's why the asymptote that goes across would have to move up 7. So it starts at y equals 0, and if there's anything out here, you add that to it. Get a question? Okay, stay with me then. All right, so here's another one. Y equals 3, x plus 2, x minus 1, all over x squared plus 7. Which one is it? Bigger on bottom, bigger on top, or same on both? Very good, it's same on both. Do you get why a lot of people would think it was bigger on the bottom? Because it has a little squared there. But if you actually multiply this thing out, it'll have a squared too. So it's the same on both. So if it's a same on both, what are you supposed to do on those again? Ratio. So it's y equals what over what? 3 over 1. Very good. Yes, sir. Yep. Why do you need the 0? Because if I just say it's the outside, people get confused, like, well, there's nothing there. And then they're like, what do I put? So I like to say 0 plus the outside. Because it starts off, most of them, to be honest, don't have anything on the outside. Does this have anything outside? No. So it's better to say y equals 0 for most of the cases. But if there is something outside, you got to add that to the 0. So 0 plus the outside. So Bob is an outsider. Do you guys still read that in English class? The outsider? Okay. All right, so let's try another one. Y equals 3, x minus 4 squared up there now, all over x to the third. Bigger on bottom, bigger on top, same on both. This is a Bob. So therefore, y equals 0 plus anything on the outside, but there's nothing on the outside, so y equals 0. So there'd be an asymptote at y equals 0. All right, let's do one problem together. It'll look like this. And then we have to do one thing with learning how to take a graph and make an equation for that. But for right now, this one, I'm going to start by factoring it. I know you know how to do this, so I'm going to save us some time and just factor it. And this becomes x, and then how do I make a 15 and a 2, plus 5 and minus 3? That sounds good. Sounds believable. Okay. Did anything cancel? And therefore, there's no hole, right? All right. And the nice part is I don't have to rewrite it as the resulting function. This is the resulting function right there. Okay, so now, what's the domain? Domain is all real numbers except x cannot be, you can always start that way. X cannot be what? Negative 5, and x also cannot be 3. Okay, now those two things are either asymptotes or holes. That's the way you should do this. They're asymptotes because there is no holes. So the asymptotes, there's two of them. X equals negative 5 and x equals 3 because there's no holes. How do I know that? Because nothing canceled. So there's no holes. And then the last thing is the horizontals. That's what you just learned. Is this bigger on bottom, bigger on top, or same on both? It's a Bob, and therefore it's y equals 0 plus anything on the outside, but there's nothing on the outside of the fraction. So y equals 0. That's it. It shouldn't be that bad. Now, there's a couple other little twists like this. If they give you the picture and you have to write the equation for it, that can be tricky, but it's really not that bad. Everybody get to this picture right now. And turn your iPads my way so that I know you're on the right picture. All right. Still waiting for a couple people, but I can see they're scrolling through, so we're fine. Okay, good. Thank you. Now, you start by just writing y equals, act like there is no hole. What's the equation for it if there wasn't any hole? Y equals 1. Very good. Now, do you get that these are all fraction functions? So I'm going to put this over 1. Now I've got a fraction. Next, I have to put in a hole. The hole is always something that cancels, right? So I need the identical thing on the top and the bottom, and I want that to be at where x is 3. So therefore, here's the most common mistake. Because if I put a 3 in here, it's going to make a 6, and that's not what I want. I want it to make 0. X minus 3 and x minus 3. That's the equation for that line. Because as soon as this cancels off, the equation is back to y equals 1 again, but we remember that this created a hole right there. So when you have a picture like this, same thing. What's the first step? Act like there's no hole. And you say, what's the equation for that line? That's just a quick reminder. It's something like this. It's got a slope and it's got a y-intercept. Remember those kind? So what's the y-intercept on this guy? 1, 2, 3, 4. 4. So 4 goes right here. And then what's the slope on this guy? I'm not trying to make this tricky. I think I actually just should tilt it a little less, like maybe like that. Slope of 1 is what I was going for. Okay, so there it is. But I put it over 1. And now what does it also need? You got to be careful by saying a hole. But it needs a hole. I'll say Yes, math is naughty lately. Okay, you just wait. There's more coming. Okay, anyway, this one, I need an x, and then where is the hole, actually? It's at where x is 1. So I'm going to put in a 1 and a 1, and I just got to be careful with this part. Is it minus or plus? Minus. That way, when you put in this positive 1, it will make a 0. Okay, there we go. That's it, except one little thing. It's wrong. Only one little thing wrong with it. Do you remember that whenever you have big fractions, everything on the top and everything on the bottom is in parentheses? I'm going to backpedal here and say when we were right there, what was there really on the top? There were parentheses right there. It'd be easy to forget that, wouldn't it? And then, because see, now when I put this hole in here, x minus 1 and x minus 1, now the 4 has to be multiplied by it, but so does the x. It really won't even matter that much because this is going to cancel anyway, but I wanted you to know that you needed those parentheses there. Just be careful with that. That would have cost you half a point in the test. All right, moving on. Here's the last one. Everybody start with the parent function for this guy, and then put in something that would create a hole at 3. So write me an equation for this. First thing, if you don't know the original one, you're kind of toast. So I'll start you off with that. That's the parent function. You got to have them memorized. Use pencil. Actually, write on the paper, though. I'm aware that you have one. I want you to use it. Okay, so then, help me out. I know that has to be there. What goes in there? X minus 3. That creates the hole that we need right there. That's it. So you start by writing the thing without the hole. Then you just slap in something like this that would cancel, and that creates the hole. Questions about that? Yes? Good question. The holes are just little, just like they sound, they're little holes in the graph. The asymptotes are big, long lines of dots. Totally different thing. So the asymptotes here, I'm going to go back to the original picture. The asymptotes here are the blue lines, and I'll move this over so you can see them better. I guess this graph is all tied together. So can you see that there's dotted lines? Okay, those dotted lines, those are asymptotes. Totally different than those little empty spots like that. That's the hole. Okay. All right, last kind of problem that you have to know how to do, we're going to actually find on the worksheet itself. I'm going to do, there's 2 of them on the worksheet. I'll do one with you. That's where they give you the asymptote lines, and you have to figure out what the equation would be. All right, so right now, I'm going to pause for a second while you find your homework for today. It's called 9.7 Day 2, assigned on March 11th. Okay, if you found your homework, here's what it should look like. I'm talking about right now number 8. All right, number 8. So everybody look at number 8 off the homework, and I'll help you with that one. And then you can try number 9 on your own. All right. First of all, it's create a rational function. I know right away that means I have a big fraction. And now I got to put stuff on the top and stuff on the bottom. Now these little clues that they're giving me are going to tell me a lot. They told me y equals 0. Do you recognize that one? Is that a bob, a bot, or a sob? It can't be a sob, a same on both. Otherwise, the ratio would have had to have a 0. How could you have a 0? You'd have to have 0 over 0, and then it doesn't even exist. So it can't be a sob. It's a bob. Bob is what gives you y equals 0. Bob is a 0. Andy's an outsider. Anyway, so this is a bob. That tells me it's a bob. So when I'm done, I better make this thing bigger on the bottom. Okay? Yes? Nope. Bots is no bots. That's different. 0 I know seems like none, but a bob is actually an asymptote at 0. As opposed to a bot, there wouldn't be any asymptotes. Okay, so this is a bob. Now what? Well, that just means when I'm done, I can make this anything I want as long as it's a bob. Okay, one more thing though. It's also got to have these 3 things, which those are X ones. Those are not horizontal. They are the vertical ones. Remember, they're vertical. Okay, so these are vertical asymptotes. Where do I get those from? The bottom or the top? Bottom. So I need something down here that accounts for those 3 things. You get where I'm going here? All right, so if there's something on the bottom that would make this be an x equals 2, wouldn't that be like an x minus 2? Get what I mean? And x equals 0 could just be an x, or you could say x plus 0, but it's the same thing as x. All right? So when it's all done, there's not just one answer. There's a lot of different ways you could do it. As long as you come out with one that's bigger on the bottom, and it has these 3 things also on the bottom, then there's an unlimited number of possible answers. But you better not, by accident, put something big on the top, because then all of a sudden it's the same on both, and that's not going to work. It has to be bigger on the bottom. So these do not have just one right answer, but you have to create one where it would have bigger on the bottom, and it would have these 3 asymptotes, which means those 3 things have to be on the bottom. All right, this next one is not a bob. I'll tell you right now, it's got to be a what? A ratio, which is a what? A sob. Same on both. So you know this next one has to be an equation that's same on both, and it tells you a couple of things that have to be on the bottom. So anyway, you can figure it out from there. All right, this assignment's a little bit long, so I am going to have you skip problems. I'll do that for my class. That's all I have for the video.